This is page 2 of your Chapter 7 review worksheet, and we'll start with problem number 6. You have integral of tangent cubed x times secant squared x dx. So for this one, if I let u equal tangent of x, then du is equal to secant squared x dx, and then there's a perfect substitution. So then that would be u to the third power du, and that's equal to u to the fourth over 4, and then I just substitute in u is equal to tangent of x, so you end up with tangent to the fourth x over 4 plus c. In the next problem, you have sine squared x times the cosine squared x. So since they're both even, you can't break off either one of them, so you're going to have to use the double angle variation of each of them. So sine squared x has the formula 1 minus cosine 2x over 2, and the cosine squared x is 1 plus cosine 2x over 2. So then I'm going to multiply them together, and that gives me a 1/4 out in front of the integral, and then 1 minus, and if you multiply the outer and the inner, it cancels out, and then the last term is a minus cosine squared of 2x dx. So I need to now rewrite the cosine squared 2x, and so this is also another variation of the cosine double angle. So instead of having a x, I have a 2x, so that will make this 2x as a 4x. So that's how I end up with a 1 minus cosine of 4x over 2. And then I'm just going to distribute everything, so I get 1/4. 1/4 times 1, and then this is a 1/2, and then you're multiplying it by a 1/4, so it's a negative 1/8, and then it's a 1/4 and another 1/2, and they're both negative, so that this will become a positive, so it's plus 1/8 cosine of 4x. And so you can combine these two as 1/8, positive 1/8. So then if you take that integral, you get 1/8 x. And then for this one, you'll do a u sub of 4x. So then the constant that gets pulled out is going to be a 1/4. So 1/8 times a 1/4 gives you 1 over 32. And the integral of cosine is sine. So it's sine 4x and then plus c. Okay, for number 8, this is x plus 5 over x minus 5 dx. And so I'm going to use a clever technique here of making the numerator, so part of the numerator, equivalent to the denominator. So I have a x minus 5 in the denominator, so I'm going to make the numerator as a x minus 5. And I don't want to change the numerator, so I need to add a 10. And so if I simplify the numerator, I still get a x plus 5. And the reason I want to do that is I'm going to split off this fraction so that it's x minus 5 over x minus 5, which is 1. And then the other fraction is 10 over x minus 5. So then this integral will be integral of 1 is x, and then this is going to be 10 times the natural log of absolute value of x minus 5, and then plus c. Okay, for problem number 9, I'm going to first calculate the integral by using the tabular method. So the derivative is x squared, and then take that derivative is 2x, and that derivative is 2, and then you get 0. On the integral side, you have sine of 2x, so that integral is negative 1/2 cosine 2x, and that integral is negative 1/4 sine of 2x, and that integral is 1/8 cosine of 2x. So I draw in my arrows and then make it go plus, minus, plus, and then I'm going to take the product. So this line right here is the product, and then I need to evaluate it from pi over 4 to 5 pi over 4. So I'm going to be putting in, first of all, top, so that is the 5 pi over 4, into all of my x's. So x here, here, and here. And so you get this line, and you end up with the angles to be 5 pi over 2 for each one of them. Okay, and then what's out in front is the 5 pi over 4 put in for x. Cosine of 5 pi over 2 is the same thing as cosine of pi over 2, which is 0. So this part here will drop out. Sine of 5 pi over 2 is the same thing as sine of pi over 2, so that's going to be 1, so that's going to stay. And then cosine of 5 pi over 2 is going to be 0 again, so this will drop out. So that's for the upper. And then for the lower, I'm going to put in pi over 2 or pi over 4, and then all of the angles are going to become pi over 2. So I have cosine of pi over 2, sine of pi over 2, and cosine of pi over 2. And in the same way, the first and the last one, since they are cosine of pi over 2, those will drop out. So the only one that I'm really interested in is the one with the sine in it. And so I have 5 pi over 8, and then I'm subtracting pi over 8, so that gives me 4 pi over 8, so the overall answer is pi over 2. Okay, problem number 10, I have sine cubed x, which is a odd power, so I'm going to break off sine x dx, and then sine squared x times cosine squared x. So since I want sine x dx to become eventually my u sub, I want to make the rest of this here to be in terms of cosine. So I'll rewrite sine squared x as 1 minus cosine squared x, and then cosine squared x, I just rewrite this, and then I distribute it, so that gives me cosine squared x minus cosine to the fourth x, and then sine x dx. So I do the u sub of u is equal to cosine of x, and du is equal to negative sine x dx, so I brought the negative to the other side, and then I substitute it in, so I end up with a negative u to the second plus u to the fourth du. And then I integrate that, which gives me a negative u to the third over 3 plus u to the fifth over 5 plus c. And then I'll substitute in u equals cosine of x. So my answer is negative cosine cubed x over 3 plus cosine to the fifth x over 5 plus c.